Good morning, everyone, and welcome to this presentation. I am Enrico Zimuel, technical lead and principal software engineer at Elastic. And today I would like to introduce you how to build a RAG system using Llama3 and LLPhant in PHP, of course. So I will introduce you how to the world basically of a large language model. And we will cover this agenda. So I will briefly introduce to you generative AI. I will talk a little bit about deep neural network that are the basement for large language model. I will also mention something about prompt engineering, how to use the large language model. And we will focus mainly on the retrieval-augmented generation. That is kind of architecture that provides you the ability to extend the knowledge of a large language model without fine-tuning it. And I will use Llama 3, actually 3.1, the latest model by Meta, and PHP, of course, and Elasticsearch as a database vector. So let's jump into the presentation. So, generative AI is everywhere. It's a kind of a buzzword at the moment. But technically speaking, this is a subset of deep learning area. So it's basically a way to have machine, artificial intelligence system that are able to generate text, images, or other media. Basically, this model learn the patterns and the structure of the input training data. So typically, these generative AI models are trained using a vast amount of data, large amount of data, and this model tries to catch the similarity between the input data. It's used everywhere, from hard to writing, coding, healthcare, finance, literally everywhere. And this is why it's so disruptive, because you can apply generative AI in all the fields. It's also important from a business side, because 2 years ago the market value was about $10 billion, and there are estimations that this can grow 10 times in 10 years. So it's quite exciting from a business point of view. But how this generative AI and large language model works? So basically, I mentioned that these are giant neural network. So a neural network is basically a method that teach computer to process data in a way that is inspired by the human brain. So as you can see here in the diagram, we have the nucleus and the dendrites of our neural in our brain, and inside there is a cell, and basically each nucleus, each neuron is connected to another one, and it can basically propagate the electric signal in our brain. This can be represented by a mathematical model using different kind of inputs, sum, so basically a way to add the input together, and using a simple function, you can basically decide which kind of input you want to propagate to the next neurons. So technically speaking, here we are using nodes. So you have to imagine there is this kind of topological schema where you have these nodes that are connected to each other. Basically, the nodes are collected in layers typically, and if we have more than 3 layers, we call it deep learning network. So just to give you an idea of how a single neuron works, so basically, as I mentioned, we can have multiple input. In this example, we have just 2 input, x1 and x2, with 0.8 and 1.2. These are just numbers. Each layer is connected with this sum here. So basically we have 2 weights, 1.0 and 0.75. So these are the weights. So basically you can specify the weight of an input. Inside the sum we have a bias, in this case 0.5. This is another constant basically. and you have a activation function here. So basically, the activation function is a mathematical function. In this case, in this example, the ReLU one is the very basic activation function that say if the input is greater than 0, is 0 or greater than 0, so the output is the input itself. Otherwise, it's 0. So if you want to represent this on on an X and Y plan, this is the function. So basically, for all the numbers, negative numbers here, the output is 0, and for the positive number is the input itself. So this is G. So if we put the number here, we can see that basically what a single neuron is doing is a sum of some products. In the specific, we are multiplying x1 with w1 plus x2 with w2 plus b. So if you do the math here, the results would be 2.2. And if we pass this number to the G, the function, the output will be 2.2, since this is positive. So again, I don't want to go more in deeply into the technical details about the mathematics, but this is just to give you an idea what kind of mathematics is inside a single neuron of a neural network. So if we want to represent a network, we can have, as I mentioned, we collect typically the neurons into layers. In this example, we have, this kind of circle that represents the input, the blue one. We have the yellow in the middle, and we have the green in the output. So if we have more than 3 layers, internal layers, so the yellow one, we call it deep neural network. Okay, if we want to represent the generative AI, as I mentioned, is a subset of deep learning. That is a subset of machine learning, and machine learning is a subset of artificial intelligence. So we will focus basically on generative AI part. So as you can see, it's a subset of different, areas of artificial intelligence. Okay, so let's jump to the large language model. So basically, I mentioned already that it's a giant neural network with many, many parameters, typically billions of weights or more. They are trained with a large quantity of unlabeled text using self-supervised learning. What does it mean? Basically means that in order to train this large language model, you have to collect huge amount of data, and to train the model, you basically give you some example, you remove randomly a word in a sentence, and you ask to the LLM to predict which word has been removed. So that's more or less how the large language model are trained. Internally, a message, that is a sentence, is split into tokens, and each token is translated into a number, because as I mentioned, a large language model is a neural network, and a neural network, as I show you, is a kind of function that gets a lot of different inputs and provide with some mathematics the output. So we have to convert the tokens into numbers, so the word into numbers, and this is called embeddings. So basically, this model, the large language model, works by taking an input text and repeatedly predict the next token or the next word. So basically, you give an input that is a sentence to the large language model, and the large language model is able to predict the next word, the word that will complete the sentence. Just to give you an idea, if we take GPT-4, it's about 1.76 trillion parameters. It has more than 120 layers, and it's processed up to 25k words at once. In order to train GPT-4, they used a 10,000 NVIDIA E100 GPU for 11 months. So more or less, this is about $200 million. If you compare the size of GPT-3 with GPT-4, that is the comparison. As you can see, huge difference. The bigger, the better is the model. So that's the trend that we discovered recently. So how this large language model works? So basically, we can think as a black box where we provide a text that is called prompt. So kind of a question, for instance, where is Ganymede located in the solar system? And the LLM gives you an answer. Basically, it's try to complete the sentence. So it's try to, for each word, to find the most probable word that completes the sentence. And for us, this is an answer. But for the machine, it's just a sequence of words with a high probability. It's important to, from an engineering point of view, to understand that there is a limit of the input size that you can, of the question, of the context that you can give as an input to an LLM. And this is called the context window. How the LLM is able to predict the next word. So basically, this is a diagram that shows you the end of all the LLM. And here we are talking about the transformer architecture. So technically, this is the real invention that gives the possibility to have this era of large language model. So at the end of this schema of the transformer, you have this basically output, a list of words with a probability. For instance, in this example, we have cake, donut, banana, apple as the next word. So maybe the discussion, the context was about, food. And the most probable one is cake with probability of 0.2. So 20% of probability cake is a good fit to complete the sentence. So this can be an option. So I will always take the most probable one. So they try to do this, in the paper of Transformer, but the output was not really human. It sounds like a robotic, sentence. Instead, what they invented was to, okay, let's just focus on the top key answer. For instance, key equal 3, so the most 3 probable, predictable word, and just pick up randomly one of these. So for instance, donut. If we apply this kind of mechanisms inside the LLM, they found out that the output actually was more human readable, more human, more close to a human speaking. And also, since we introduce random here, is important because we can generate different response, different, sentences each time. So that's why they call it generative model, because are able to, with a little bit of random here, to generate different output. And actually there is a very important parameter that every LLM has, that is the temperature. This kind of parameter numbers that you can use to amplify the probability. And actually, the more higher is the temperature, the more generative is the model. So if you put temperature 0, typically you will have always the same answer. If you put a number greater than 0, you will start having different output. If you do the same question to an LLM, you will get different, kind of outputs. And this is nice because from an engineering point of view, we can leverage this parameter to get, different output, more generative. Okay, so in this presentation, I will use Llama. Llama is a tool to be able to install locally a large language model. Of course, you cannot run all the models unless you have a very robust hardware, but generally speaking, the Llama 3 or the recent Llama 3.1, the 8 billions model, you can run it on your own laptop. So Llama give you the possibility very, very easily to download the model and run locally. There are very simple API here. So basically it's a command line tool. You can download a model using the Llama pool command. you specify the name of the command, for instance, llama3.1, and you can just run straight away. So typically this model, for instance, the 8 billion sounds like 4.7 gigabytes, the size of this file. So it's basically one file that you have to download it, and you can run easily after you download it. Of course, it depends on the hardware. So if you have a good GPU, the speed of execution of this model will be better. But even if you don't have a GPU, they will run on a single CPU. Of course, very, very slow, but at least you can try it. Talking about PHP, we will use this project, LLPhant, that is an open source project. It's a kind of LangChain for PHP, but not with all the features of LangChain. It's just a very simple focus on the simplicity to talk with an LLM using the API. It supports OpenAI, it supports Llama, Mistral, and also different vector databases, because inside LLPhant you can actually use the RAG architecture. So there is a class offered by the project that give you the possibility to extend the knowledge of a model using a vector database, like Elasticsearch, or even a simple file, or other database like Quadrant, Redis, Milvus, etc. It's a project started by Maxime Townsend, and I also contribute to this project. Just to give you an example how it's simple to use. In this example, we are using Llama3.1. So we are just specifying the model inside this property of the Llama config class. And we are creating an Llama chat. So Llama chat basically is the class that gives you the possibility to chat, to send questions, to send sentences to the large language model. For instance, I can ask what is the capital of Italy, and I will get back the response in a variable, in a string. Very straightforward. Okay, I promise you that we are going to create a RAG system. So, but what is a RAG system? RAG is an acronym of retrieval-augmented generation. So it's a technique that is basically a way to extend the knowledge of a large language model, and is composed basically by two parts: the retrieval-augmented and the generation. So let's focus on the generation part first. So, as you know, LLM are very powerful, but they are limited in the sense that they don't provide any source, any evidence about the answer. So when you ask something to, I don't know, Llama3 or ChatGPT, they give you an answer, but they didn't say, okay, I give you this answer because I, read this paper, because this information has been retrieved by this website, etc. There is no source. And that's why typically they can hallucinate. So they can try to invent an answer, because technically speaking, I already mentioned that they are just a way to complete a sentence. So they don't care if the sentence is good or not from a semantic point of view, or if this is completely invented, it is fake news. They just try to complete a sentence. So you can have a potential hallucination. So there is no way to verify actually the output from an LLM. And another limitation is about the out of date, because typically these LLM are trained using a fixed amount of documents, but they cannot know about news. And actually in the demo that I'm going to show you, I will show you how to enhance an LLM with a news, with a new information. So basically, as I said, they are trained in a period of time, and in order to expand, you have to retrain everything. So this is very cost effective, as I mentioned. We are talking about millions of dollars. So basically, what we want to do is to collect a set of private or public documents. We want to build a retrieval system. So basically, we need a database where we put this document, and we want to extract a subset of this document using a question, so in natural languages. Imagine that we have a database, we put some documents inside, we ask for a search This is semantic search. And we will get back a subset of documents that potentially are close to the question. So we pass the question and the documents found to an LLM, asking with a prompt that say, look, I found this document, so according to this document, please provide me an answer. So basically we use the LLM just because it is able to speak in English, in natural languages. But the content, the information about the answer are stored into our private database. So if we want to represent this using a schema, so basically from the left to the right, we have a question that we ask to a database. So this is kind of a search. Of course, here the database is a vector database, and I will show you what this means in a minute. In this database, we can collect our documents. For instance, we have a company, we have private documents. We want to offer a way to talk, to chat with this document, to add the knowledge of the document to an LLM. We put in our database, so this is something that we control, so it's not in the LLM. So the database, as I mentioned, is able to give you the results, so the documents that are more close from a semantic point of view to the question. We can collect, I don't know, 3-5 documents, the top 3, the top 5 documents, and the same document plus the question we can pass to the LLM asking, please, using this context given by this subset of documents, give me an answer. So that is the schema. As you can see, we are not putting the documents inside the LLM. We are just storing the documents into the database. So this is very good from a privacy point of view, because in this way, we don't expose the documents to the LLM. For instance, if you are using ChatGPT, documents will not be stored into the server of OpenAI. So, but how we can retrieve documents in a database using a question? Because typically we are familiar with, database, and you have to provide a SQL instruction in order to select, to provide a query. So this is kind of a new database. We need to use semantic search, and we need to use vector. So inside the database, we are going to store vectors. For instance, we are going to use Elasticsearch in our demo. A vector database, so basically is a system that stores vectors that are basically set of numbers to retrieve the information. So, but what is a sector? It's a set of numbers, so it's an array, if you want to see from a PHP perspective, of float. For instance, this is an array of 3 elements, 2, 5, and -10. Typically, in the LLM, for instance, Llama 3.1, it uses 4096 dimensions. So you have to imagine that for each document, you have 4096 numbers, floating point numbers. So it's a very big array. Of course, if you want to represent it from with some diagram, we can go up to the 3 dimension. Up to the 3 dimension, we cannot see how this model works. So we are very limited. But the most important part here is, okay, I have these vectors, but how I can search for documents that are similar to this vector? So we have to introduce this concept of similarity. So the similarity of 2 vectors is basically a measure of how the 2 vectors are similar. And if the vector are representation of a sentence, this gives us the semantic similarity. Because 2 sentences are similar, that means they are talking about the same topics, more or less. This depends on how we translate the sentence into vectors, the embedding part. So we can use different kind of similarity approach. One of the most used is the cousin. So it's basically just a formula that if you see, for instance, it's 2-dimensional, the vectors, if 2 vectors are similar, the angle between the 2 vectors is closed, or you can just measure the Euclidean distance, whatever. So we can use one of this similarity. Again, one of the most used is the cosine, so the angle between the vectors. But how we can actually translate sentence, word into vectors? This is called embeddings, and you can do not just for sentences, but also for images, sound, movie, whatever. And typically they use the LLM to do this. So when you provide an embeddings, and I will show you Llama3, so we are using the model of Llama3 to give us the embeddings, so the sentence, the vectors, that is the representation, the mathematical representation of a sentence. And how is that internally? It's using a neural network again, but more or less, just to give you an idea, what these embedding model are doing are trying to represent the words here or the sentence into a multidimensional space, putting together the word or the sentence that are similar. For instance, here we are putting grandfather, man, adult, woman close to each other. So they live in this, cluster. And at the bottom, you can see boy, child, infant, girl. So this kind of word are similar in some regard, and they are put, more close to each other. So the idea here is that the LLM is able to generate this multidimensional space, putting all the different, words in the correct position, according to all the documents that the model digested. So if we have this, we can actually provide semantic search. So the search query is actually the question in natural languages. And so we use semantic search to retrieve the top hand documents that are more similar to the vector. And we just provide a prompt like this to the LLM. Given the following context, where you have to think that context here is the list, so the copy and paste of all the documents found by the vector databases, answer to the following question. And the question is the same question that we use for the vector databases. To do this, so to insert actually, to provide these embeddings in a vector database, we need to split the document. Imagine you have a, PDF of 20 pages. You cannot just put all the pages into a vector database. You have to split the content of the PDF into chunks. So this is important because the size of the chunk depends, of course, on the model used by Llama, in this case, Llama 3.1. And you have a limit of 128K. That is pretty big because in the past we was talking about 4K, 8K. So Llama 3 introduced a very big context window. But again, you have to take the document and split into chunks to be sure that all the possible meaning of the chunk are represented right with embeddings. Because otherwise, if you put a big document and you just try to embed it, this will cover just the beginning of the document, potentially the end, but the middle part of the document will not be covered by the embedding system. So you have to be sure that the size of the context that you're putting into the vector database is compatible with the dimension used by the embedding model. So basically we split the document into chunks, and for each chunk we do the embeddings and we store it into the database. So what we are going to do now is show you how to build a RAG system using Llama3, Elasticsearch as a vector database, and LLPhant to run the code in PHP. You can check it out, the example in this GitHub repository. So what you have to do is, of course, install Llama3.1. So you have to install Llama and run this command, Llama pool Llama3.1. After we can ask, actually, I try to, to do this exercise to ask to Llama3.1, how many moons has Neptune? And typically, if you run Llama3.1 and you ask for this question, you will have an answer like the moons that I know for Neptune are 14. So you should see something like this. And this is not correct because recently some astronomers discovered other 2 moons of Neptune. So the right answer should be 16. But of course, Llama 3 doesn't know about this because this is a new discovering that has been done after the training of Llama 3. So after you have to download the example and install it. So just clone the repository and run composer install. And after we have to run Elasticsearch and Kibana, that is a tool to a UI for Elasticsearch locally. So we want to run Elasticsearch locally, and you can easily do this running a single command. So in the GitHub repository that I show you, this PHP LLM example, you will find under the bin folder a simple bash script, start local. If you run it, you will have Elasticsearch and Kibana running on your machine with a trial version. After, we need to take the documents that we want to put in the Elasticsearch. And which kind of document? I provide an example, a PDF that has the news about this new discovery of the moons of Neptune. So the idea is we want to improve the knowledge, we want to update the knowledge of Llama 3, putting these news documents and ask again how many moons has Neptune. So we need to run this command, this embedding PHP file, just to execute the instruction to read the PDF file and store it into Elasticsearch, and I will show you in a minute the code. And after, we can ask to the RAG system how many moons has Neptune. Again, I will show you the code. The file is qa.php, and you will see something, an answer like, according to the text, Neptune currently has 16 known moons. And this was possible because we had the knowledge using this RAG approach. Okay, so now I will show you the code. So basically, here we have a very simple example, PHP script, where, as you know, I just focusing on Llama 3.1. I'm using LLPhant, the project that I mentioned. And I'm just, this is a chat implementation. So if I run here PHP chat Llama 3, they ask me, okay, ask me anything. So I can ask how many moons has Neptune. And in some seconds we will have the answer. Of course, the speed here depending on the kind of laptop and CPU and GPU that you have on your machine. As you can see, we have the kind of a long response with all the details. Now to Neptune, the 8th planet in our solar system, has a total of 14 known moons. So according to the knowledge of Llama 3.1, Neptune has 14 moons, and you have also the list of the moons, blah, blah, blah. But again, this is not correct because the information are not up to date. There has been a new discovery, so the total number should be 16. So the goal is to add this information into Llama 3. So what we are going to do is to store the knowledge that is basically this PDF file, where there is basically a copy and paste from an article of CBS News with all the information about the discovery, how they find the news. So basically, this is an article that I get from the CBS News website. So here we are just using again LLPhant. We are reading the PDF using this class file data reader. We need to split the documents again into chunks, and here we are splitting in 1K characters, and we need to generate embeddings. And how we do this, we are using the Llama embedding generator. So basically Llama is the tool that runs Llama 3.1. So here we are using the Llama 3.1 embedding system. So they will generate 4K floating point numbers for a single vector. And after, we can index all the embeddings to Elasticsearch. So what we have to do, as you can see here, we are just creating an instance, a client instance for connecting to Elasticsearch that will run on localhost with port 9200. That is the default port of Elasticsearch. We are using as an index name Llama. An index name is the name of this kind of collection of documents, and we are just storing it. So if we just execute, if we just execute this from the command line, we can write PHP. This is called embedding, right? So we are reading the file, we are splitting the file into 5 chunks, and we are storing it to Elasticsearch. So now this article about the new discovery of Neptune has been inserted into Elasticsearch. So now I can actually show you the RAG system. That is very, very simple using LLPhant. Basically, you have to provide the generator, so the embeddings. Again, we are using Llama 3.1, the Elasticsearch. We are just creating an instance of Elastic Vector Store. So we have to specify the name of the index, remember was Llama. And now we are using the RAG. RAG is a question answering class where you pass the vector store, the embedding, and the chat, where the chat is actually the model. And if we ask how many moons has Neptune, we will see in a second the output. So as you can see, the output is according to the text after the latest discovery. Neptune now has 16 known moons. So we extended the knowledge of Llama 3, putting this additional document, but we didn't train again the model. We just use this RAG approach that is able to extract subset of the information and pass right away to the LLM. But also interesting to notice, we can provide the content. So we can say, look, I give you this answer, and the document that I used are this. So as you can see, there is a list of documents here with the content. So I can, prevent hallucination, because I can say, look, I give you this answer according to this knowledge that I have, to these documents. So you can literally show the source that the model used to generate the answer. And I think this is very, very convenient, especially if you want to put more trust in this system. Okay, so I basically finished my presentation. I put also some references, you can check it out. And that's it. So we'll wait for answer, and thank you very much for your attention.
Hi, Enrico. Many thanks for your speech. It was really awesome. And as for me, as for a PHP developer, I'm shocked at what we can do just right now. And just thankfully to LLPhant. How it is correctly to pronounce this library to work with? LLPhant. Oh,
yes.
LLPhant.
Yeah, because
okay,
it's a French.
got it.
It's a French project, so you have to use the French accent here.
Yeah, I got it. And just a quick question: which machine you are using for your local development, and what will you suggest as a local development machine for LM and just for Llama 3,
Yes.
and what will be the best?
Yeah, as I mentioned, you can actually run everywhere, but the speed, of course, will change according to the power of your laptop. In my case, I'm running on a ThinkPad laptop with a GPU NVIDIA 3060. So it's quite powerful, I would say. But generally speaking, again, it will run the new model, the 3.1, especially with the one reduced to 4-bit. So of course you cannot run the big model on a machine like this. You need a server with a special GPU. But for the small one, the 8 billion, small, not so small, but very, very good actually for testing. You can run it on any laptop.
And will it work okay with MacBooks on M processor?
Yes, yes. If you have
Yeah.
a Mac,
Okay. Yeah.
especially the new one with the the new processor, that will run faster.
Okay. Yeah, I got it. And maybe what is the average cost of using own Llama on AWS to get normal production results?
To be honest, I have no idea because I'm not using directly into AWS. But you have to, of course, for a production system, you have to compare the cost of running in your environment or in a cloud environment, or even if you want to use a completely external, solution like OpenAI. You have to check by yourself the cost, but I cannot give you an answer at the moment. Sorry.
Okay, yeah, just in comparing with chat with OpenAI, where you are paying for each request, maybe at some point it will be a little bit cheaper, but you don't have possibility to provide your private data.
Yeah, I think
And maybe.
yes, that's the point. The point of it's the really power of this technology of the RAG system is the possibility to run locally because you want to have privacy on your documents. So I think that's very powerful.
And maybe can you suggest from your own experience some best examples of best cases of using Llama models on production?
Yeah, for instance, we are using in Elastic, we build our knowledge for the company, all the information regarding, documentation, even a QA. We have also using this in our QA system. So basically, when someone asks for something, the first shot is to use this RAG system to give you an answer. If the answer is okay, we can just say, okay, that's a good answer. So we just give it to someone as a output. Otherwise, you can actually get it, edit, changing a little bit. It's a very successful way for us. And we also built in our products. So we are, for instance, for the security one, we are using the knowledge that the system has on your system. So according to the history of your system or the log of your system, the LLM is able to provide the answer. So it is very specific by you, by your history data. So I think there are, again, is disruptive because you can apply everywhere, right? So the only limitation is your imagination, actually.
And really with this LLPhant library, we can use it even with PHP, and it's really awesome. And mm, have you compared the results of on your projects with ChatGPT? For example, you said that you're using um, your own Llama models for generating documentation, for answering questions about Elasticsearch, and have you compared the results with ChatGPT?
Oh, if you use the RAG system, we show that basically Llama 3.1 is very close to GPT-4. Very, very close. Even because the very powerful here is the fact that you have to retrieve the proper documents. You are not really leveraging the knowledge of the model itself. So it doesn't care a lot if you're using a very sophisticated a general purpose LLM like GPT-4 or Llama 3, because the knowledge is the one that you provide. So in this architecture of the RAG, the most important part is actually the retriever part. So how do you build the semantic search and the vector database? That's the most important one. Because literally we are just using LLM as a English or Italian or French speaking, whatever you want to use it.
Okay, I got it. And just one more interesting question about performance. Elasticsearch is really fast fast and powerful search engine for even if you're using it with PHP. But if you're adding some models, it will significantly reduce the performance of your application. Maybe just you can answer which performance metrics, which speed of response time is okay if you are using LLMs.
Yeah, of course, this is a good question. This is actually depending on also the amount of documents that you have to manage. Because if we are talking about millions of documents, you have to provide a system like Elasticsearch. This is able to give you an answer in less than half second, more or less. That's is the standard, output of Elasticsearch. But if you want to use, I don't know, 100 documents or 1,000 documents, you can even try with less, technology from a performance point of view. So it's literally, it depends on the kind of documents, on the kind of performance that you are looking for, because you have to sum this output plus the output of LLM. That is, generally speaking, is the most expensive is the LLM. So you can wait according to, I don't know, 1 second, 2 seconds, 10 seconds, depending on the power of your GPU system.
Yeah, and it's really a tricky question. With Elasticsearch, you've tried to do really fast responses, and now you cannot do like this. Just need to find this balance with generating
Yeah,
answers and
we are investing a lot of energy. A lot of our R&D at the moment in Elastic is focused on how we can simplify the implementation of a RAG system. So, for instance, what we did was to add internally in Elasticsearch a model itself that is, we call it ELSER. That's a kind of B5 with steroid, I would say. And automatically, when you insert something in Elasticsearch, a document, you can use this model internally. So you don't have to do nothing. You just put data inside Elasticsearch, and Elasticsearch is able to chunk the document, to split, create embeddings, and everything. So we are constantly focusing on how we can simplify the developers to use our technology without doing a lot of steps, because I showed in the demo there are some steps you have to do. Of course, it's not so trivial, but still there are a lot of questions. How should be long the chunk, for instance? How many characters I have to use? This is according to the model that you pick up. You have to run the model locally. So if you want to index 1 million of documents, of course you have to wait a lot. So we are trying to simplify this process, basically.
Yes, thank you for response. And one more. Have you tried to integrate or to use LLPhant together with Symfony? And if yes, is there any challenges what's need to be solved?
I didn't use by myself, but I know a lot of people are using it, since it's kind of the author actually of LLPhant use Symfony a lot, so they I think it's very, very straightforward to use it. But again, I'm not a Symfony expert, so I cannot give you
Okay, yes, thank you.
better answer.
And one more question. Is there any limitations for amount of documents for RAG?
This depending on the databases you are using. So the vector database, for instance, in Elasticsearch, you don't have a limit. The limit is the amount of nodes, amount of RAM, amount of disk that you have.
Yeah, thank you. And one more, maybe the last from our viewers. Are there any benefits using Llama 3 against OpenAI engine? And can we integrate RAG with OpenAI?
Yeah, you can use a RAG system with OpenAI, of course. You have just to change the configuration that I show in the code instead of Llama 3 using OpenAI. The advantage of Llama 3 that you run locally, so you don't have to pay for the API, even the latency, because we have to remember each time we use OpenAI, there is an HTTP connection between the client and the server and the response back. So you have to also to consider that part. And for instance, if OpenAI is not available, your system will not work anymore. So if there is no HTTP connection, that's kind of a problem.
Yeah, you're definitely right about OpenAI has some problems with connections if you're using it in production. You might need to find workarounds for them. Yeah, thank you, Enrico, one more time for your presentation. It was really awesome. I just want to test Llama right now. Thank you for this.
Yes, no problem. Thank you for inviting me to this amazing conference. Thank you.
Bye.
Bye-bye.